We're going to solve a system of linear equation in 3 variables. I have 3 equations. Equation 1 is this plane, equation 2, and equation 3. And we want the intersection of the 3 planes. So what we're going to do this technique I'm going to show you will work for any one of the problems. We are going to intersect the first 2 equations, and that's going to give us equation 4. We're going to intersect that by eliminating one of the variables. So in this problem, we're going to eliminate a variable, and we're going to get equation 4. Then we're going to look at the last 2 equations and eliminate the same variable, and that's going to give us equation 5. In that case, we will have 2 variables in the new equations because we've eliminated a variable. A diagram of what we're going to do is this. We're starting with 3 equations with 3 variables. We're going to get it down to 2 equations, E4 and E5, with 2 variables, and then from there we get it down to 1 equation with 1 variable, and we get 1 value. And then we can work our way backward to get the actual answers. So I'm going to demonstrate this technique, which is foolproof. It always works. First step is we're going to choose to eliminate a variable. So let's eliminate the variable y. I'm going to eliminate y from the first 2 equations. Looking at this, I have negative 4y and positive 2y. So I see that to do this, I'm going to multiply equation 2 by positive 2. So to do this, the first equation 1 stays as it is, and it's just equation 1, and it's 2x minus 4y plus 3z is 17. Now I multiply equation 2 by 2. So 2 times equation 2 gives me 2 times x, 2 times 2y is 4y, 2 times negative z is negative 2z, 2 times 0 is 0. Using the process of elimination, the y is eliminated, and this new result I call equation 4. And it is 2x and 2x, 4x, 3z and negative 2z is positive z, 17 and 0 is 17. This is equation 4. Now we're going to eliminate the same variable from these last 2 equations. So we have to eliminate y. We can see we have a positive 2y here, and equation 3 is a negative y. So we're going to multiply equation 3 by 2. So that means we keep equation 2, which is x plus 2y minus z is 0. Now I multiply equation 3 by 2. So 2 times equation 3, 2 times 4x is 8x, 2 times negative y is negative 2y, 2 times negative z is negative 2z, 2 times 6 is 12. I now have created equation 5. Using the elimination, my new equation 5, because I've eliminated the y's, is 9x, negative z and negative 2z is negative 3z equals 0, and 12 is 12. We now have changed this to 2 equations with 2 variables, and we're now ready to eliminate one of those variables. Putting those 2 equations, equation 4 is 4x plus z is 17. Equation 5 is 9x minus 3z is 12. I'm now ready to eliminate either the x or the z. Now I can eliminate the z easily if I multiply everything through by 3. So now doing that, I have 3 times equation 4 is 12x plus 3z. 3 times 17 is 51. And equation 5 is 9x minus 3z is 12. So now I can eliminate the z. 12x and 9x is 21x. 51 and 12, 1 and 2 is 3, 5 and 1 is 6, is 63. And we're almost getting one of the coordinates. So now we divide both sides by 21, which gives us that x is 3. Now that's just one of the coordinates. We now have to go backwards and work our way back with the 2 equations and eventually the 3 to get the y and the z value. I'm now going to take and substitute x equals 3 to get the z value in either equation 4 or 5. So I'm going to use one of those. And the easy one seems to be equation 4, which I had up here. In this problem now, if I let x equal 3 in equation 4, I get 4x plus z is 17. So substituting in 3, I get 4 times 3 plus z is 17. 12 plus z is 17. Subtracting 12 from both sides, I get that z is 5. I've now gotten a second coordinate. At this point, I now am going to go up here. I have x is 3, z is 5, and I am going to choose one of the 3 original equations to substitute. I'm going to use equation 2 to get the missing coordinate. So now I'm going to substitute x being 3, z being 5 in equation 2. So I get 3 plus 2y minus the z value is 5 is 0. I have 2y, 3 and negative 5 is negative 2 is 0. Adding 2 to both sides, I have 2y is 2. And from this, dividing both sides by 2, I get that y is 1. Once I have that, I have the ordered triple. That's the solution. And the solution, that is that point in 3 space, is x being 3, y being 1, z being 5. And that's my solution.